We're going to demonstrate the use of VisIt to calculate the average velocities of a number of different fragments of some sort of exploding device. Now I've created some fake data here using our noise data set and a threshold operator. So it's basically creating bits and pieces of something, and if you look at the velocity vectors on each of these pieces, they appear to be sort of moving outwards from central areas. So I've created this sort of fake data. There are these fragments that are basically being blown apart, and I want to know what the average velocity of each one of these pieces is. And so what you see being plotted here is the pieces. That's the pseudo-color plot with some pseudo-coloring of them, and then the velocity field over those pieces, and I'll just hide the pseudo-color plot for a minute. So those are the velocity fields of the pieces. Don't know why VisIt did that in the window, but anyhow, now I want to actually compute the average velocities of each one of these pieces, and the key to doing this is to use the connected components query. So we go into controls, query here, and I'll point out what it is that we want to use. We want to use the connected components weighted variable sum query. What that will do is calculate the weighted variable sum of the value over each of these pieces. It's weighted by volume in this case because it's a 3D mesh. The challenge with using this query is it appears to only work for scalar data, and we have a vector field here. So what we're going to have to do is do this query 3 times, once for the x component, the y component, the z component of the velocity vector, and then sort of patch that data together. So let's get to it. So we're going to go into expressions, and I'm going to create the x, y, and z components of the velocity vector. So we'll call it vel x. Oops, sorry. And that's going to be the 0th index of velocity. Oops, guess I didn't need to do that. Sorry about that. Let's start over. Okay, vel x is going to be my velocity vector, and I'm going to take the 0th component of that, and then likewise vel y velocity, and take the first component of that, and then the last expression is vel z, and I'm going to take the second component of that. So those are my 3 scalar fields now. Hit apply, and what I'm going to go up here and do then is I'm going to hide these 2 plots, and I'm going to add the pseudo color for vel x here, draw that, and now I'm going to do a connected components query, weighted variable sum query of vel x. And what I get here now is the volume weighted velocity in the x direction for each of the 14 little fragments that we see in this main window. Now I'm going to change this variable to vel y and perform that query again. So now we have that query repeated, except it's for velocity in the y direction, and I'm going to do this again. I'm going to change the variable to vel z. Now it's plotting velocity z there, and do that same query again. So now I have 3 values for the velocity, the x, y, and z. So then what I do is I put these in 3 different files. So there's 3 different files there. That's the query on the x component, query on the y component, and then the query on the z component. And then I just used shell command line to paste these files together and filter it out. And when I do that, that's this command line right here. Let's see. I get, oops, I see that the command line is being cut off. Let me shift this over just a bit. that's the command line. The first part of the command pastes the three files together. Then I translate all the tabs to spaces, and then I do cuts at spaces to get the velocity values, and then finally I do some more filtering on it. So that command, when I run it, boy, I don't know why I'm cutting and pasting the wrong stuff here, but gives me these vectors then. So this is the velocity for the first component, the average volume weighted velocity vector for the first component, the volume weighted velocity vector for the second component, and so forth. And if you really want to see which components are which up here, you can do some additional work to know which components each of these velocity values goes for. But that is basically how you would compute the average velocities of all these different fragments.